I want to talk about some week 9 and 10 quiz questions. Let's get right into it. Question 1 is about Markovnikov's rule. This basically says that when an alkene undergoes an addition reaction, the bigger atoms are going to be added to carbons that already have big atoms on them. So if we're adding water, the question is, where's the OH going to go? And this carbon has, it already has 2 carbons bonded to it, so it is richer than the carbon on the left, which only has 1 carbon bonded to it. So the OH from the water is going to go here, and the H from the water is going to go on our carbon to the left. All right, number 2. All we're doing is just naming this compound. Step 1 is find the longest chain of carbons. And there it is, 4 carbons, 1, 2, 3, 4. And then we remember the prefix for a 4-carbon chain, which is bute. So I guess we only eliminated propene as an answer here. And then it has a double bond, so this is not an ane, but an ene molecule. I guess that doesn't help us much. But okay, let's see. Let's get to the trans part. So this is a double bond which does not rotate. So this methyl group here and this methyl group here are stuck on whatever side of the bond line that they're on right now. And they are across from each other on different sides of this bond line. And the word for that is trans. If they were on the same side, it would be called cis. So if this methyl was down below, it would be a cis molecule, but it is trans because they're on opposite sides. Okay, so I'm looking at this molecule here, and I see a triple bond. So that means that the ending has to be not ane or ene, but ine. So it's one of these top 2. And the number here has to tell us where that triple bond is, and we can just count from the closest side, carbon 1 and then carbon 2, and we're already there. So since the triple bond is at the second carbon, this is 2-heptyne, and you might want to just check to make sure that there are 7 carbons in here, because that's what hept means, the 7. Right. I'm going to let you guys do this one, but here's a hint. First step is find your main chain of carbons, and here it is. It's 3 carbons long. This is not a carbon. That's a chloro substituent. Okay, so ordering boiling points of alkanes. Here the thing is, think about methane. That's a gas, right? Think about ethane. That's a gas. So they've essentially boiled off below room temperature. They have really low boiling points. But as you get bigger, think of octane. There's octane in your gasoline. So that's a liquid at room temperature. Its boiling point is above room temperature. So as we get bigger, the boiling point goes up. So basically, this is just rank these by size. Let's see. So if we know our prefixes pretty well, we can do this pretty well. Here it looks like this one is biggest to smallest, which means highest boiling point to lowest. Okay, this one's a bit of a mess, but if you look at it long enough, you can see there's only 1 or 2 possible reasonable answers here. This one's ridiculous because there's no way you're going to add 3 hydroxy groups from one water. But Markovnikov's rule here is telling us that the carbon that's already bonded to more carbons is going to get the bigger atom from the water. So the oxygen is going to bond, that big oxygen is going to bond to the carbon that's already bonded to big carbons. So this top one shows the OH on the middle carbon, which is what Markovnikov tells us should happen. Okay, methylhexane. Methylhexane has 6 carbons in its parent chain, and then it has an extra carbon in this methyl group. So it's going to have an extra carbon than hexane, which only has 6. Let's see, a bunch of true or false here. You guys can handle those. Okay, a heteroatom is not a carbon or a hydrogen. So yeah, all the first functional groups we look at have oxygen in them, and ether is not an exception. So an ether has an oxygen that's sandwiched between 2 carbons. So number 15, a trick here is that we want to number our carbons such that we get to the triple bond as soon as possible. So here we number from the right. So this would be carbon 1, and then 2, 3, 4. So it looks like our triple bond, our ine, is on carbon 3. So this one looks good. Oh no, that's carbon 2. Carbon 2. 1, 2. So we're looking at a 2 ine. So either the first one or the fourth one are good choices here. And then our methyl's on the 4th carbon. Okay, so we got 2 of those still, okay. Yeah, the thing is, this is a methyl, not a propyl. Propyl would have 3 carbons, so we can eliminate the 4th one and go with A here. Oh, and I guess we didn't talk about this much in class, but this is diamond. Graphite has planes. It has a bunch of sheets of carbon, and then this, well, carbon monoxide isn't just pure carbon. Obviously, it has oxygen in there. Okay, another naming one. So step 1. What is step 1, everybody? All at once now. It's find the parent chain. So 4 carbons in the parent chain. That means this is a butane, and the substituent is a methyl group, and it's on the 1, 2, 2nd carbon. So we got 2-methyl butane. You guys can see this type of reaction on your a lot of the processed foods you eat. They're partially nated. Okay, pent means there's going to be 5 carbons. If this was an alkane instead of an ene, we would have twice as many hydrogens plus 2. So this would be a good answer for an alkane, but that double bond removes 2 hydrogens. So, here we go. 2 less hydrogens corresponds to an alkene down here. Hydration, we've seen that adding water puts a hydroxyl group onto a molecule, and that makes it an alcohol if there's an OH bonded to a carbon with a single bond. You guys can look that up. What does saturated mean when you're talking about oils? Saturated means full of hydrogens, which means lacking double bonds. So hydrogenation gets rid of double bonds and adds hydrogen. And if you don't have any double bonds in the molecule, you don't call it an alkene, you call it an alkane. So this is what we're going for there. Oh, and we're done. All right. Congratulations if you made it this far through the video. Good luck on your quiz. Let me know if you have any other questions.